While looking for microcontrollers with HID capabilities, I came across this DIGISPARK ATINY85 board online. It was the cheapest board I could find in the market with HID capabilities. So I got it and made a mouse with it. In this video, I'll go through all the parts and the code and show you how you can make one too. This is the DIGISPARK ATINY85 board. It has 6 input-output pins, of which pin P3 and P4 are used for USB positive and USB negative. I also have this joystick module which I will use to move the cursor, and the 2 buttons for the left and right click from a mouse. The joystick module gives the X and Y position as an analog output. We will feed this analog data to pin P2 and P5, which are the 2 remaining analog input pins on our microcontroller. The 2 buttons will connect to pin P0 and P1 respectively. We'll also use pull-up resistors. You can follow the schematics and try out your connections on a breadboard first. With this, we are done with our connections. Let us take a look at the code now. The first and foremost thing you need to do is install the board manager and the drivers required for our microcontroller. You can click on this link and get detailed instructions on how to do that. The first thing we need to do is include the DigiMouse library. It comes along with the board manager, so you don't need to install any separate libraries for it. In the setup section, we will define pin P0 and pin P1 as our input pins. We will connect the 2 buttons to these 2 pins, which will serve the purpose of the left and right click. The analog data from pin P2 and pin P5 will be saved in the variables X and Y. Our cursor will move in the X and Y direction based on how much the joystick has been moved in a certain direction. When the buttons are not pressed, the values at pin P0 and pin P1 are high. This is due to the pull-up resistors we have added in our circuit. When you press the first button, it gives a low input to pin P0, which triggers a left click. Doing the same to the other button triggers a right click. When none of the buttons are pressed, a no click signal is given. After every loop, our data gets updated. This happens every 50 milliseconds. We are now ready to upload our code. Select the correct board type and upload your code onto your microcontroller. With the code now uploaded, your mouse is ready. You can find more information and the schematics regarding this video in the description below. If you enjoyed the video, hit that like button and don't forget to subscribe for more.